Okay, grade 8, this is your formative quiz answers to your 6.1, 6.4 formative quiz on fraction operations. Your first question was a true-false. Your first 5 questions, I guess, were true-false. And the first one said 3/5 multiplied by 2 is the same thing or is equal to 1 1/5. Well, if you had 3/5 of something, and I can draw it here, you had 3/5 and you were to double it, so I'm going to take this and just click on it and clone it. That would be multiplying it by 2. And you ask yourself, well, how many fifths would I have? I'd have 1, 2, 3/5, 4, 5. I'd have 6/5 altogether. Now 6/5 is an improper fraction, but if I was to change it to a mixed fraction, it would be 1 1/5, which is this answer, which makes this true. I could also have just taken an algorithm that said 3/5 multiplied by 2 and thought about 2 as being just 2 over 1. That's the same thing as 2. When you multiply those together, you would have 3 times 2 over 5 times 1, which would still give you the same answer, just a different way without modeling it. The second question says 5/6 divided by 2 is less than half. Remember, I read this, and this was not eating it, not eating. So because it was not eating what I said, I must read it as less than. So 5/6 divided by 2 is less than a half. Well, let's check. So if I had 5/6, 1, 2, 3, 4, 5. So 5/6. This is less than 1. And if I take something that is less than 1 and divide it by 2, I will always get something that is less than half. That's going to be true because 1 divided by 2 is exactly half, right? If I have 1 chocolate bar and I divide it between 2 people, everyone gets a half. So if this fraction is less than 1 and I divide it by 2, my answer will be less than half. That is true. But we can double check our answer. We can double check it. So take 5/6, divide it in half. This is mine. This is my wife's. So if I have 5/6 divided by 2, my new denominator would be 12, and I would have 5/12. And 5/12 is less than half. Why? Because 6/12 is half, and 5/12 would be less than half. Question 3 says 5/8 divided by 2 is the same thing as 5/8 multiplied by a half. Let's check. So if I draw 5/8 and I have 5/8 and I divide it by 2, this is mine, this is my wife's. Here I would have no longer divided into 8 parts, but rather 16, and I would have 5 parts of those 16. My wife would have the other 5 parts out of 16. But if I did 5/8 divided by 2, I would draw the exact same thing, except I would say 5/8 divided by 2. This would be each person's cut, or half of 5/8. So the answer would be the same thing, 5/16. So they are true. Dividing by 2 and multiplying by a half gives you the same thing. Actually, hold it. I have to redraw that. So this picture, though, would be a little bit different. Let's look at it. So this says 5/8 of 1/2. My mistake. So if I was to draw a half, and I was to take 5/8 of that, I would cut it in half, cut each of those in half. There's 8 parts. 5/8 would be 1, 2, 3, 4, 5/8, which would be no longer a denominator of 2, but rather a denominator of 16. I'd have 1, 2, 3, 4, 5 parts out of 16. Same answer. Question 4 says, when modeled, 1/2 times 2/3 is equal to 2/3 times 1/2. When modeled, now that's the key part, when modeled. Are they the same thing? So for this particular one, 1/2 times 2/3 is 1/2 of 2/3. So when I look at that, I'm going to draw 2/3, and I'm going to take half of it. That's the picture for that. But for the second one, it's 2/3 of a half. So I'm going to take a half, and I'm going to do 2/3. Is it the same picture? No. Is it the same value? Yes, but not the same modeling picture. So the answer for this one is false. They're not the same picture. Multiplying a proper fraction by a proper fraction will always be less than 1. Is this true? Well, a proper fraction is any fraction where the numerator is smaller than the denominator. And if I multiply that by any other fraction, let's say a half, I will always have something less than 1. This is true. And watch what I mean. So if I have a proper fraction, in this case a half, I am starting with something less than 1. And by multiplying it by a fraction, I'm actually taking less than or a part of this fraction. So if I have 2/3 of a half, I would still have something less than a half. So in this case, 1/3, 2/3, I would have 2/6, which is actually 1/3. So when you multiply a fraction by a fraction, you're actually getting part of a proper fraction, which means it has to be less than 1. Question 6 is your distributive property question. So if I have 1 2/5 multiplied by 2 2/3, that means I have 1 times 2, and I have 1 times 2/3. I have 2/5 times 2, and I have 2/5 times 2/3. And that's best illustrated when we look at that area model for multiplication. So if I was to make this into an area model, this could be 1. From here to here is 1. From here to here is 2/5. From here to here would be represented by the number 2. And from here to here would be the number 2/3. So inside here I'd have 1 times 2, which is right here. Inside here I would have 1 times 2/3, which is represented right here. Inside here, I'd have 2/5 multiplied by 2, which is represented right here. And the last one, I would have 2/5 multiplied by 2/3, represented right here. So using the area model and distributive property, any way you think about it, you still get the missing part would be 2/5 times 2/3. Question 7 is just a numeric response and answer. So what is 4/5 times 2? Well, if you solve it with modeling, you can think about it. I have 1/5, 2/5, 3/5, and 4/5. And if I double that, I would have 8/5. If you use just an algorithm, you have 4/5 multiplied by 2 would be 4 times 2 over 5 times 1, which is 8/5, which is still 1 and 3/5. Both ones. Question 8's a little bit different. It's 5/2 times 3. So if I was to draw this question, this is kind of interesting. There's 1/2, there's 2/2. So this is actually 2/2. This here would be another 2/2. So altogether, I would have 4/2 or 2. And if I had one more half here, altogether, this would be 5/2 or 2.5. Okay? So this picture represents 5/2 or 2.5. We're going to call it 5/2. And if I was to triple it, I would take it. I would, well, first I'll have to group it, and then I will infinite clone it, and I'll get 2 of them. And then I have to triple it, so I'll get 3 of them. And really, since we're dealing with an improper fraction, I just want to know how many halves do I have? Well, I have 1, 2, 3, 4, 5, 10. I have 15 halves, which would be represented as 15 halves, or 7.5. The other way we can think about that is I have 1, 2, 3, 4, 5, 6. These two together make 7.5. Both can be counted the same way. The other way you could solve this question is not by modeling, but simply using the algorithm. You could say 5 over 2 multiplied by 3 as a fraction would be 3 over 1. Multiply your numerators, multiply your denominators. You get 15 over 2, which is still 7.5. Question 9 says, what division statement is represented by this model? Well, clearly, if we're thinking about chocolate bars like we usually do, we started off with a chocolate bar that was 4/5 of a bar. It was not complete. And then Will, Ed, Tom, and Pete decided to share this 4/5. So we took the 4/5 and we divided it between 4 people. Okay? And as a result, instead of having a denominator of 5, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a denominator of 20, and Will, or each person, will get 4/20. Okay? Now 4/20 is a fraction that we know is not in lowest terms. We can reduce it by a factor of 4. Give me 1/5 as my answer. Now somebody might say, well, I wouldn't have cut it at all. I would have said, well, if I have 4/5 of a bar, and I wanted to share those with 4 people, I would give Will this one, I give Ed this one, I give Tom this one, I give Pete this one. So I wouldn't have to cut it at all. I just snap off one of those pieces of the chocolate bar, and this fraction here is actually 1/5 of a bar anyway. So there's 2 different ways to interpret it, but the actual answer is it's 4/5 divided by 4. Question 10, 5/8 divided by 3. So if I wanted to draw it, I could go, 8ths would be like this. There's 5/8 divided between 3 people. There's Will's, there's Tommy's, and there's Earl's. Will, Tommy, and Earl are sharing this. So I now have a chocolate bar that's divided into 24 parts, and each person will receive 5/24 of a full chocolate bar. Okay? 5/24. Question 11. What multiplication statement is represented by this model? Well, we started off with 2/3, and we quadrupled it, or we multiplied it by 4. So the answer is 2/3 multiplied by 4. And if you wanted to make it an equation instead of a statement or an expression, you could say that that is 8/3 or 2 2/3. Question 12 says, what multiplication statement is represented by this model? Well, I started with this amount of chocolate, in this case 1/7, and I cut it into thirds, and I kept 2/3 of the 1/7, or 2/3 multiplied by 1/7. Question 13 is your simple, it doesn't have to model it, so I'm just going to use my algorithm here. So 4 times 5 over 5 times 6 equals 20 over 30, which equals 2 over 3, because I can divide both by 10 to reduce it to lowest terms. Now this is an interesting question because this is a great example of cross reduction. If I was to swap the numerators and go 5 over 5 times 4 over 6, so just swap the numerators here. The 4 goes where the 5 was, and the 5 goes where the 4 was. When I get to this stage, right here, I would have this as my product, and I would still end up with exactly what I did up here. The only difference is I swapped the numerators. But the interesting thing of realizing that by swapping the numerators you get the same answer, in my original question back here, I didn't have to start with 5 over 5. I could actually start with 1 over 1 because I can reduce that initial fraction down to 1 over 1. And instead of 4 over 6, I could reduce it down to 2 over 3. So instead of multiplying 5 over 5 by 4 over 6, I could really multiply 1 over 1 times 2 over 3, which would have given me the answer 2 over 3 right away without having to do any of this right here. I would have gotten the answer. That's called cross reduction. And if I look at that question again, so my original question was this. Since I know this 5 could be over here and this 4 could be over here, I can pretend that those numerators are where they are. And what I can do is I can put my lines through it just like I did here, and I can reduce that down to 1 over 1. And I can put lines through the 4 over 6 just like I did here, and reduce it down to 2 over 3. And so what I'm really doing is I'm cross-reducing. I'm looking across the fractions in the product of those two fractions, realizing this could have been what it looked like, and I could have gotten the same answer, but I'm going to cross-reduce it. And when I do that, it makes my numerators easy to multiply, my denominators easier to multiply, and I end up with my answer without having to do all of this stuff here. If you got that, great. If you didn't, we'll work on cross reduction later on. But for now, we'll just realize that the answer to this question was 2/3. Question 14. Using the algorithm, I do 2 times 1 over 3 times 8. That would be 2 over 24, which in lowest terms is 1 over 12. Question 15. Now you could solve it by modeling, or the easiest way to solve the multiplication of two mixed fractions is to simply think about them as improper fractions. So 1 2/3 is really 5/3 multiplied by 1 2/3, which is 5/3. Then I just multiply my numerators, multiply my denominators, and I get 25 over 9. That is the answer. However, you can change it back to its original form, which was a mixed fraction. How many 9s in 25? There's 2. That's 18 with 7 ninths left over. So 2 and 7 ninths is the answer, or 25 ninths. Question 16 says 2 1/2 multiplied by 3/4. Again, I'm going to take this and think of it as an improper fraction. I'm going to multiply my numerators and multiply my denominators. I get 15/8, which is going to be 1 7/8. Question 17 says model. Well, we've been doing it all along, so I'm going to take 1/5 and triple it. Doubling it would look like this, and tripling it would look like this. How many fifths do I have altogether? I have 3/5. Question 18, I have 1/5 of a chocolate bar. I'm going to share it between 3 people, or divide it between 3 people. I'm going to give this to Cindy. I'm going to give this to Billy. I'm going to give this to Al. Each person would no longer have a fifth of a bar, but rather a denominator of 15, and each would receive 1/15 of a full chocolate bar. Question 19 is 1/5 times 2/3. In order to model it, you need to read it as 1/5 of 2/3, because the multiplication sign can be interpreted as of. Draw your 2/3. 1/5 of 2/3 would be this much right here. Your denominator was 3, but when you make those cuts, it's now 15. And if you keep 1/3 of it, you get to keep 2/15. So the answer is 2/15. And the final question is model this. This is the hardest one when you model the product of two mixed fractions. So we're going to use our area model for this. The distance from here to here is 1. The distance from here to here is 1/5. The distance from here to here is 1. The distance from here to here is 2/3. And yes, I know that this one looks a lot longer than this one, but we're not doing it to scale. We're just imagining it. So inside this square would be the product of 1 and 1. This one would be 1/5 and 1. Inside here would be 2/3 times 1, and this would be 2/3 times 1/5. Okay. So if I do this one's the easiest one. The product of this is 1. The product of here is 1/5. The product here is 2/3. And the product here, using my algorithm, would be 2/15. So what the area model is saying is 1 and 1/5 multiplied by 1 and 2/3 would give me the area of the entire shape. But if I separate it into 4 smaller things, the sum of 1 plus 1/5 plus 2/3 plus 2/15 would be the same thing as if I just did the multiplication of those two, because the areas would be the same. So in doing this, I'm going to just keep my 1 down here. I'm going to bring my whole numbers down, and all I'm going to do is focus on the fraction parts. So if I'm adding those 3 fractions together, the first thing I need to get is a common denominator. In this case, I'm going to use 15. And 1/5 is equivalent to 3/15. These are the same value. 2/3 is equivalent to 10/15. And 2/15 just stays as 2/15. And now that I have common denominators, simply add the numerators. 3 plus 10 plus 12 is 15. So the sum is 15/15, which is really 1. So therefore, the answer to the area is 2. All 4 areas added together is 2, which means that 1 and 1/5 times 1 and 2/3 is equal to 2. Okay, that was an easy one. All right, if you have any questions, come see me about the review if you need extra help. I can arrange some extra help after school if you'd like. And hopefully you understand everything we did in the video here.